Hello, everyone. My name is Oh Junjie. Today, I want to talk about the proof of derivative of Leibniz formula with induction. These are the contents I want to talk. The introduction. I will talk about the history of Leibniz formula. Then I will talk the important is the proof of Leibniz formula. Finally, we do some examples. Now we look at introduction. Gottfried Leibniz, he was the invention of Leibniz formula. And he was also a German mathematician who independently developed the present-day notation calculus, like differentiation and integration. Although he never thought of the derivative as a limit. So he was the invention of calculus in the middle of 1670s. And his philosophy is also important. And he also invented an early calculating machine. Before we talk the proof, let us see the formula first. This is the Leibniz formula. The formula is the product of f and g of the bracket of n of power is the derivative on n order is equal to the sum from k equals to 0 to n of the big bracket of nk is the binomial coefficient times the derivative on n minus k of f times the derivative on k of g. Now we assume the functions f and g have the derivative up to n order. Now consider the derivative of the product of these functions. The first derivative, we know that is f plum g plus g plum f. And second derivative, we can plug this equation to this equation and differentiate one more time. We'll get f plum plum g plus 2f plum g plum plus fg plum plum. And the third derivative, we also can use the same way to do. We'll get f plum 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 g plus 3f plum plum g plum plus 3f plum g plum plum plus fg plum plum plum. We do n times, also can use the same way to do. Differentiate. So from this relationship, we know that these formulas are similar to the binomial expansion raised to the appropriate exponent. So we can write the general formula for the derivative on n order of the product of functions fg. We'll get this equation. Now we can prove with induction. So the basic step, when n equals to 1, we'll plug into the n, we'll get the sum from k equals to 0 to 1 of the binomial 1 to k times the derivative on 1 minus k of f times the derivative on k of g. Then the inductive step, we can take an intermediate index 1 to m to n, will get the sum from k equals to 0 to m of the binomial of m to k times the derivative on m minus k of f times the derivative on k of g. Same as the previous formula that I said. Then we can take the derivative on m plus 1 order. We can use the formula to differentiate one more time. So after we use the product rule to differentiate, we'll get the sum from k equals to 0 to m of the binomial of m to k times the derivative on m minus k plus 1 of f times the on k of g, plus the sum from k equals to 0 to m of the binomial m to k times the derivative on m minus k of f times the derivative on k plus 1 of g. Because the binomial m to k is a constant, so we can just leave it. And the second term, we set k equals to k minus 1. We'll get the binomial of m to k minus 1 times the derivative on m minus k plus 1 of f times the derivative on k of g. Because we can directly factorize by the derivative on m minus k plus 1 of f times the derivative on k of g. And then we can plug into the second term. We'll get the sum from k equals to 1 to m plus 1 of the binomial m to k minus 1 times the derivative on m minus k plus 1 of f times the derivative on k of g. And then we can, and then the sigma bottom will be changed to k equals to 1, and the sigma above will be changed to m plus 1. Now we can rearrange the equation already. We can now consider the first term. We can let k equals to 0 to put it outside, to substitute into the equation, plus the sum from k equals to 1 to m of the binomial of m to k times the derivative on m minus k plus 1 of f times the derivative on k of g. So these are the equation is from the first term. And then consider the second term. We may set the k equals to m plus 1. So consider the last term. We'll get the binomial m of m to m times the derivative on g0 of f times the derivative on m plus 1 of g, and plus the sum from k equals to 1 to m times the of the binomial m to k minus 1 times the derivative on m minus k plus 1 of f times the derivative on k of g. So these are the second term. These are the equation from the second term. Next, from the second and third terms can be factorized by the derivative on m minus k plus 1 of f times the derivative on k of g. So the binomial m to k plus the binomial m to k minus 1 can do the addition by Pascal identity. Will get the binomial m plus 1 to k. So we can plug into the equation like this. After these three equations add up, will be the sum from k equals to 0 to m plus 1 of the binomial m plus 1 to k times the derivative on m minus k plus 1 of f times the derivative on k of g. So by principle of mathematical induction, we can find that the Leibniz formula is this formula. Look at the example. Find the fourth derivative of the function e power of x sine times sine x by using Leibniz formula. Is equals to the sum from k equals to 0 to 4 of the binomial 4 to k times the derivative on 4 minus k of sine x times the derivative on k of e power of x. So consider the sum from k equals to 0 to 4. K is equals to 0, 1, 2, 3 until 4. So we can plug in these numbers to sum up. The binomial of 4 to k is from the binomial 4 to 0 sum up to the binomial 4 to 4. Sine x derivative 4 times will be sine x, and sine x derivative 3 times is negative cosine x, and sine x derivative 2 times is negative sine x, and sine x derivative 1 times is cosine x, and sine x derivative 0 times should be sine x. And then e power of x derivative how many times, also e power of x. So for computation, we can get this answer. negative 4 times e power of x times sine x. Thank you for my presentation.